All right, welcome. What I want to do is I want to introduce you to what a limit is and how limits work. And we're going to talk about, I want to talk about how to find limits using a calculator both algebraically and numerically. Now, what we're going to do is we're going to first find out what a limit is and how to find this. Well, a limit is an intended height of a function. It's something that you're approaching but that don't really get you. I have a definition of a limit, and you can see this. This is from a book that I found. All right, it's on Calculus 1 and how to find limits. And it says if f of x becomes arbitrarily close to a single number L as x approaches c from either side, the limit of f of x as x approaches c is L. Okay, now what does that mean? Well, what we're asking here is we are going to find f of x. F of x is our output. Okay, and we want to figure out that that becomes arbitrarily close. Arbitrarily close means very close or really close, all right, to a single number L. Now this L that we're trying to find, this L is what we refer to as the limit. So essentially, limit is an output. It's a y value that we are approaching, all right, that we get really close to. And how do we do that? Well, we do that by setting x, because x is going to approach the c value. All right, from either side. So that means we're going to approach the c, our input, that's our input, all right, from both sides. And as we get closer and closer to this, what we notice is that we can write the limit of f of x as x approaches c, and this is what we say, and that's going to equal L. And so that is a standard informal, non-formal definition of a limit that you see in many calculus textbooks and whatnot. And we're going to talk about now is an example of how this applies. And you can see this problem right here. So what we have is I have a limit of this function at x cubed minus 1 over x minus 1. Now this looks like an equation of a parabola. And as you see this, we are going to be looking at what is happening. All right, so essentially using the definition, we want to find out where is the value, define our limit, where is the output approaching as x gets closer to 1 from either side. So what does that mean? Well, how do we approach 1? Well, 1 is right here. Okay, 1 is right there. And as you look at this, all right, 1, we want to get closer and closer to 1 to the left. Now, this is how we write this. We can take what's called the one-sided limit. The limit as x approaches 1, with that little minus sign, means to the left, okay, of this function f of x. So I'm going to start plugging in values. I'm going to get really close to 1. And as I get closer to 1, you realize I have outputs. And I'm going to have outputs that are going to be coming closer and closer to the intended value. So what we're going to do is we're approaching a value that appears to be approaching 1, 2, and 3. It appears to be approaching 3. Okay, so I'm going to put 3 here because it appears to be approaching 3. And now that is from the left side. Okay, so remember we have to approach from both sides. All right, so now we're going to approach the same thing. We're going to approach 1. Now from the left side, now we're going to actually approach it from the right side. So I'm going to approach, all right, 1 from the right side of the function. And when you see this little plus sign, all right, above the 1, that means we're going from the right side, all right, of 1. So I'm going to go to the right side of 1. Now I'll change my color here, make it green. And so as I get closer and closer to this value, you can see that I'm going to plug in values, all right, and get closer and closer. And you see that it is approaching this value right here, which once again appears to be, all right, this L value, all right, output. The L that we're approaching, or that value, is going to equal, or appears to be 3. Now, because the right and left side, the right and left side approach the same value, that output that they're getting arbitrarily close to is L, and L happens to be 3. And so we would say our limit is 3. Now, we can find this using a graph, as you can see that I have one laid out here. But if you take out your calculator, and I have mine right here, we're going to use our calculator to help us figure out this limit as well. So I have my graph right here. Okay, and what we're going to do is we're going to find out what happens when we get closer and closer to 1, just to verify that it actually is equal to 3. To do that, we're going to plug in values that are really close to 1 to the left and 1 to the right. Okay, so we can see that we plug in values. So if I wanted to plug in a value to the left, and we can figure out a table, and that's what we'll do. Or I can go to trace. But if I want to find out my x values that I can plug in to get my y values, okay, and we'll have f of x. All right, and as we approach this from x approaches 1 to the left, I'm going to plug in some values for x. All right, and that's going to give me out some values. All right, so I'll put this down right here. Hopefully you can see this. So the values I can plug in, well, we can start out something close to 1 to the left. Now, if you look at the number line, close to the left would be, I don't know, like 0.9. So as you go over here, we can go to trace. I can punch in 0.9. And as you see, we get a value of 2.71, all right, 2.71. Well, 0.9 is close to 1 to the left, but let me get closer. So I'm going to put in 0.99. So if I go over here and put 0.99, all right, you can see that I'm going to have 2.9701, 2.9701. Well, that's close, but I want it even closer. So I'm going to put 0.999, all right, so 0.999. And you can realize that, okay, getting, well, to something, 2.997, that actually does appear that I'm getting closer and closer to what I found out before for my graph, 3. So remember, a limit is a value you're getting close to, getting really close to, but not actually reaching. Now, if you want to just get crazy, you can go put in 0.9999999, very, very close, and what you have is 2.99999, and that I can confirm is approaching 3. Now, we can do that not only to the left side, but we also want to approach from the right side, because they have to approach the same value from the right and left. So I'm going to take this, I'm going to erase it, okay? So we can confirm now that our left side limit equals 3. So now I'm going to say, okay, what happens when x approaches 1 to the right? What happens to our value of f of x? Well, a value to the right, as I get closer to this way, would be like a value like 1.1. 1.1 would be a value you can plug in there. So I'm going to go over here and go 1.1. And I can see that it's going to be 3.31. 3.31. Well, a value that's even closer, I can plug in like 1.01. All right, so 1.01. And you plug that in there. And what we have is 3.0301. All right, 3.0301. Well, let's get closer, 1.001. And I think you can probably guess, I hope, all right, is that it appears that, yes, this appears to be getting closer and closer once again, all right, to 3. And if we want to get really close, 0.0000001, and what we have is, well, it actually says its value is 3. So we just confirmed that, yes, as we get closer to 1 to the right, we are also approaching 3. And therefore, according to the definition of a limit, all right, if we approach the same value from the right side and the left side, that value that we're getting very close to, or in this case is 3, that's going to be our limit. All right, well, I hope this is a good introduction. I'm going to go through another example of how we can use, all right, a table and a graph to help us figure out what a limit is, all right, on another tutorial.